Okay, well, good morning, everyone. It's great that I can join you online. I would have loved to be there in person for the summer school, but unfortunately, due to other obligations, I couldn't. I'm Narges Darabi. I am an advisor at SURF, and I will be talking about how we use EUDAT services for doing data management in one of the research communities called CombBiomed, which stands for Computational Biomedicine, and also how we use these services and how it helped us as a community to have more fair data, which I think you have been hearing about, like having findable, accessible, interoperable, and reusable data. So let me just start with my slides. You may have already heard about SURF. SURF is a collaborative organization for IT in the Netherlands, which we support the Dutch education and research. We provide multiple services in different areas, compute, data, to help the research and education in the Netherlands qua infrastructure. And these services, as I said, they can. We have the Snellius supercomputer here. You see a picture of, but we also have cloud services for doing compute. We also have data services like the data archive or cloud storage systems for storing data. And besides that, we are also involved in many projects, research projects with the research communities. Here you see, some examples like DICE and EUDAT and FAIR. These are more like service provider, infrastructure, projects that work on providing services, but we are also engaged in community project, like, for example, EOSC, which is for the social sciences communities in the Netherlands, or CombBiomed, which I will talk about more in depth in my talk. It's the computational biomedicine community, which they do a lot of research on understanding how the human and biomedical processes work at different scales, from molecular all the way to a virtual human. And besides involving these projects, we also give consultancy and training and do knowledge exchange with our partners throughout Europe and also worldwide. So a lot is going on. Now I will keep it brief. What is CombBiomed? So as I said, CombBiomed is a research community about computational biomedicine. And there are different, let's say, target groups that are involved in this community. We have the academic users, where you will find like researchers from different academic partners, universities, doing the actual research on the topics. We also have industrial partners or users where they are involved in the project, like, for example, you can think of the pharma companies. They are very interested in this type of research because it helps them to evaluate or assess the effect of drugs, for example, in certain processes, like, for example, molecular binding or etc. And also the clinical users, which you can think of hospitals or those who are actually treating people with diseases. So, for example, one of the computational simulations that was made in this community was the simulation of the blood flow and how you can, with use of certain balloons, you can prevent, for example, a certain heart attack or diseases. So hospital, in particular the clinical community, is also very interested in this type of research. And of course, the general public is one of the other, let's say, interested, because I mean, all of us as humans, we are interested in this type of research because it has to do with our health, it has to do with how we can better treatment, etc. So again, different user group audiences, different partners, and a lot of things happening at different scales in this community. And a lot of data is being used from hospitals, but also a lot of simulation data has been created to make models from all the way from for example, molecular binding simulations all the way to making a virtual human. And one of the outcomes of this Biomed, it's actually a center of excellence, was that they made a movie of a whole virtual human. What does it mean, a digital twin of you? And how it can be used in future to have improvements in treatment that people can get. So a very interesting community research field which we were involved with. And in what follows, I would like to show you how we tried to use the EUDAT and services, data services that was used within EUDAT to make the data that is generated in this community better accessible and usable. So the data management challenges of research communities, I think it's more or less generic over all fields. Everyone needs more, every researcher or everyone doing research needs more efficient access to the data. They want to be able to share data, they want to transfer data between each other, especially when it comes to intensive data sharing, like if you want to share large amounts of data. Usually a researcher will hit barriers there. Also when it comes to restricted data. So nowadays you hear a lot about data privacy, and when it comes to restricted data, you cannot just share this data via email or send it over or even keep it at your own computer. So there is a lot of challenges there. Also preserving research data, storage, backup of the data, archiving of the data, having synchronizations of the data over distributed places. These are all things that, as a researcher or as a research project or team, you have to take care about or think about even before you start your project. How do you want to handle the data? Where do you want to store it? How do you want to archive it? And also, having accessible research data. Once research, I'm done with my PhD, for example, how do I make sure that the output of the research, the data, is accessible to the rest of the team or for those who want to do follow-up research on it? So making data accessible to the research communities, using of PIDs, the so-called persistent identifiers, to make sure that the data are findable, also using metadata for the data. And also, I think most importantly, having findable research data. I don't know the background of the people exactly joining, but I can imagine that many of you are also involved or busy, maybe writing PhD or master thesis and sort of doing research yourself, and you have been searching the literature for the data that you need. And so making the data findable to others, that it can be discovered with the right keywords, is very important nowadays for research and open science. So this is, in a nutshell, the challenges that I think every research community faces, including Biomed, which I was involved with. And in the biomed community in particular, I think the main challenge was in making data fair was that they were lacking an encompassing solution for publishing data and metadata. So there were research going on in different teams, different universities, different partners, but they were all like doing their own research, and there was no generic way to make this data or publish this data in some centric place that is all under this biomed umbrella, let's say, that if someone is interested in the work that is being done in this community, okay, where can I find the data that is being generated under this community? And also, to a lot of big extent, technical knowledge and awareness among researchers themselves. That like usually when you are doing a research, the only thing you think about is to have analyze your data, get the output data you need, write up the thesis, and finish up your research. This is, of course, the most important, but besides that, there are also factors that help this work that you have done or this research that you have accomplished make it accessible to the wider community, and that is also important. So making this awareness was also and also bringing them or giving them the technical knowledge how it can be done was also one of the other challenges we were facing in Combiomed. So one of the example research that was actually for us as a starting use case to think about how we can make use of EUDAT services was this research. It was using the so-called ALIA application. It is an application for biomechanics simulations, let's say. Well, maybe I'm putting the exact words not correct, but the research was about in silico human clinical trials for cardiac safety assessment of drugs. So, well, very clinical, but basically they were making models of hearts and they wanted to assess the safety of different drugs on this model. And the main questions they were trying to answer was why do drugs may produce different rhythmic or effects on some people and not on the others, and if they can reproduce this observed behavior to create a normal human in silico population. So it's becoming a bit clinical, I know, but I think from the clinical perspective, these questions are very important that they can answer in a safe way. They cannot just test some on humans. So they need models to be able to assess these hypotheses, let's say. With this research, they were able to produce great results. I'm not going into the detail of what was achieved, but as you see, this is the simulation of the heart, and you can see that here they for different, let's say, types of input, which was the dosage or the amount of drug, they could get different output for the rhythm of the heart. And so this was a very interesting research that they were doing in one center, namely the Barcelona Supercomputing Center and the research team there. But they, of course, needed to run the same simulations on other centers as well. Like at SURF, we have back then we had the Cretaceous supercomputer, now we have the Snellius. So this ALIA application is also installed and running on Snellius. So they needed a way to make sure that this data is becoming available in other centers as well. And when I say data, we are talking about, as you see here, like terabytes of data. In this specific use case, 27 terabyte of data. And I just searched, so ALIA stands for High Performance Computational Mechanics. It's a complicated tool, but researchers use it to make these complex models. And so the data that was fed into these simulations and was processed was huge. And they needed to make this data and application also available on other HPC centers like SURF. So the application was installed quite easily on other centers, but with the help of HPC consultants, high performance computing consultants, but still the data was a challenge for them to transfer. So what we did was we defined a workflow. So the data is being created in some lab. It was transferred to Barcelona Supercomputing Center, and there the researchers pre-processed the data, which included manual steps to automate, and automated steps to do image stitching, segmentation, meshing, etc. And then once the data is pre-processed, it needed to be replicated to the other centers, like SURF, for example, for doing also computation, but also for long-term preservation. Because if you have replicas of data in other sites, if something happens to yours, to the center in Barcelona, for example, the data is still safe. We have a replica or copies of data in SURF or in other HPC centers that are involved in the project. And also you would get access to researchers in those centers who also use the data. So we needed to replicate the data from BSC to other HPC centers such as SURF. And the replicated data will be used, as I said, to run simulations on the other sites. And also, if needed, this data could be saved there for long-term preservation. And then once the data is there, researcher can use it to analyze and do simulations. So we started with a very basic pilot, let's say, with using the B2 Safe service, which I will also show a quick slide, but I think during this week of summer school, you most probably have heard about this service. It's a service based on IROTS technology, and it's meant for replicating safe replication of the data, also defining data management policies on the data, etc. So we set it up a pilot to federate these HPC centers. So we installed B2 Safe on those centers and made federation and tried to use this federation to replicate data. But yeah, as I said, this was during the CompBiomed 1, as you see, and it was a pilot. So we needed solid support from the EUDAT community to be able to set this up. So what we did, we joined a call from the DICE project. DICE is the Data Infrastructure Capacity for EOSC, a sort of follow-up of EUDAT. And we wrote a proposal together, and this got granted so that we implement two workflows. Firstly, a data replication workflow that facilitates large data transfer by making replicas of data. And second was a data publication workflow, where we either set up or, configure a data repository for this community so that it can be used to publish data with a community-specific metadata schema. Metadata is data about data. So if I want to publish my research data, I need to be able to annotate it with which date it was created, which tools was used to be created. So to enrich the data with metadata so that it can later be findable for others. The partners that was involved in this project were, we were 3 partners, one in the UK, one in Barcelona, and one in the Netherlands, SURF. And we used 3 EUDAT services: the B2 Share service, which was the data repository, the B2 Handle, which helps to make persistent identifiers, and the B2 Safe, which is based on iRods and is to replicate data. Here again, the services that we used. So the data repository gave us the possibility to add metadata schemas to the repository and publish data under this in this repository under this schema. The B2 Handle was to create persistent identifiers to make sure that the data is findable, and the B2 Safe was for data staging and safe data replication. So basically, with the federated network of B2 Safe, we bring the data close to compute and also make sure that safe replicas are available. This is a slide about B2 Safe. I think you have already heard about these slides, so I will just skip through. Just that this is the service we used for replication of the data, and the B2 Share, which is the repository. And I think you have also heard about these services in the past week, so I'm not explaining those, but just that the B2 Share was the data repository publishing data. And so in this collaboration, again, it was not only about putting a technical solution in place. It was also about giving trainings and making awareness among researchers, and also have a good network. So I think the network that we got from EUDAT and the access to the experts that we had was one of the biggest achievements in this collaboration. And then we implemented, as I said, 2 workflows: the data replication, which I will show you, and the data publication. The aim for the data replication was to facilitate large data transfer, making replicas of data for preservation, and also assigning PIDs to them for findability, and also bringing data close to compute. For the data publication, again, we needed a data repository to publish data with metadata. We have worked on a metadata schema for CombioMed, which I'll show you later. And also, we wanted to be able to assign DOIs or persistent identifiers to the data for findability. So, in the proposal, we of course offered some, proposed some ideas and some ways to do, but then as part of the collaboration, we made detailed work plans on what is it that we want to achieve, and like detailed technical tasks. And as you see, like for example, Barcelona Supercomputing Center has deployed B2 Safe on their side. SURF already had B2 Safe running in production, so that was a great step. We were already forward, but we did help the other centers a lot in their installation, and also made sure, or took the lead that these centers get federated with SURF. So basically the Barcelona Supercomputing Center and also UCL, University College London, they both installed B2 Safe, and they federated with SURF. And also, as a service provider, we also offered the PID service or prefix to at least to UCL. So it helped them further with their installation of B2 Safe, and also making handle making PIDs. So here, what you see is the data platform that we built with this nice EUDAT and CompBiomed collaboration. As you see, we have the B2Safe installed and federated in SURF, UCL, and BSc. And this federated is tested and in place, so actual data can now be replicated among these sites. I will show you some performance tests that we did in a bit. But this is, well, great achievement, because right now, if a researcher at UCL or in Barcelona Supercomputing Center has some data, like large data in order of terabytes, using it for a research, for a simulation, and they need compute resources at SURF, for example, or other places, or if they want to transfer the data to give access to researcher, for example, in University of Amsterdam, then they can use this network of B2Safe Federation to transfer the data. We are also federated with LRZ. It's in Germany. As a compute site, because this was also one of the partners within CompBiomed, and we had a lot of collaboration with them. So again, BSc is a compute site, and they have B2Safe and installed. SURF is a compute site, but also our B2Safe is also connected to the data archive in the backend. So the data that lands on B2Safe can also land on the data archive for long-term preservation. About performance tests, so we did tested the network that we made qua performance. Here you see the performance tests between SURF and UCL, for example. With transfers, we measured the transfer speed between UCL and SURF Federation for different file sizes and in different directions. We used 4 threads in all the transfers, and as you can see, and also made different attempts. And in general, the input speed from UCL to SURF was significantly faster. And we think this is due to the firewall setup at UCL, than the other way around. And we think this is due to the firewall setup at UCL. But the fact that this federation is in place and performs in a good, has a good performance is very good. So I will show you in a bit that we are now starting with an actual use case to help them transfer the data among these sites. We also did performance tests for the connection between SURF and BSc and tested with certain file sizes, and the performance was comparable with what we get with BSc. Some interesting things that came out of these testings was that we faced an issue in transferring big files, for example, from BSc to SURF, not the other way around. And it took the experts at EUDAT and also our CompBiomed technical people to figure out what is narrow down and root cause this issue. And it all came down to the fact that transferring large file between zones with B2Safe receives an receives an error if one side has SSL enabled and the other side not. And I think this is a very interesting finding, and we reported that to the IROTS consortium to resolve it. But I think these are the things that comes up out of such a use of these tools by the communities, so that actually, bugs are being found and reported to be fixed, so that other communities won't face such a problems. So this is a research use case that we are now actually looking into to help. for migrate or transferring the data. Again, this is an interesting project that is being done at UCL, and the data need to be made available in Barcelona Supercomputing Center. And the objective of this research is that they want to do patient-specific cardiac simulations using electromechanical model validation and in silico trials. And so basically making simulation of the whole heart and see how it's performed. I'm not going into detail of this research. The slide was made by one of our research partner collaborators on Biomed, but just to show you that a great amount of effort is being done to collect this data and analyze it, pre-process it, etc. And all the way going into the simulations to make these outputs. So this data is really of great value, and they need to be able to share it and work with it in different centers. So qua data management, they actually collected this data for every patient within UCL. And it's a data set of 500 participants, including MRI sequences, medical history, demographics info. And basically, BSc required secure access and transfer of this data for their model production. So you can see that the researchers and research community are really facing obstacles there. And then, so this is the use case workflow. The data comes out from hospital, it's being stored in the data safe haven, and then it needs to be transferred to the Mare Nostrum. It's the supercomputer in Barcelona. And also, once the simulations are done, it needs to be restored back in a repository. And we are now, well, basically with the solution that we have put in place, it facilitates the second last two boxes. But we are now in discussion with the data owner and the data safe haven, which hosts the data, to sign up data sharing agreements and do risk assessments on what is needed to transfer this data. So a lot is going on. Well, now I'm moving to the data repository part, namely the B2 share for publishing data. I'm not sure how am I doing with time, Jorik. How much time do I have still?
15 minutes.
18 minutes, okay. So the data repository, as I said, the B2 share data repository, we did make an attempt to install an instance of B2 share at UCL, because these B2 services are all open source and you can just download the source code from GitHub. But what I'm now presenting is still work in progress, deploying an instance of B2 share at UCL, one of the Biomed partners. What I want to show is the work that we did with the central B2 share repository, which the link you can see here. So basically, we did make a metadata schema for Biomed, and we have published data under this schema. And well, there is a training instance of B2 share available for testing, which well, you probably heard about. But if you go to this link, b2share.eudat.eu, then you can see all the communities that are this repository, and you can also see the link for sharing. Here, if you go to the repository, here you see all. You can see all the communities that are under this repository that are made in this repository. And the idea is that if I, as a researcher, am doing research in Biomed, for example, and I need to find all the data that is published in this community, I can go there and click on the see what is being published under this community. And if I want to publish my data, I can choose this community to publish under it, and then add the metadata, metadata schema that I need to publish my data will be accessible here. You can see that there are other communities as well, like Clari, DBBMRI, some other I don't know, but there are many communities in there. And what we asked the B2Share team to make for us was the Combiomed community. So here you see a short description, but what is very interesting is the metadata, Combiomed metadata schema, which you see if you click on it, you will see the metadata fields. Some of the metadata fields are just generic, like what you get in this Dublin core, or like what is the community, what is the title of the record that you want to publish, creator, description, if it is open access or not. But at the end, there are also, you can define community-specific metadata. That is still not added for Combiomed, but we have worked with the researchers in the community to find out what are those metadata, specific metadata fields that would help them when they want to publish data. And well, maybe interesting for you to know, it mainly comes to fields related to computational methods and simulations and codes, because Combiomed is doing research in a very wide range of research, and it was really a challenge to come up with metadata schema that is related or that makes sense for all these research fields, like certain variable, like demographic information, etc. But I think they all have a common ground when it comes to computational methods for publishing the data. So we have come up with those fields. It was done as part of one of the tasks within Combiomed, and we are now going to talk with the B2Share team again to see if they can implement those metadata, community metadata fields for us in B2Share central instance. If you look into the repository, you can see that there are already data sets that are published under the Combiomed community, and this is a
is wrong. Yeah, I think I'm still connected to the. No, I still have connection to the Wi-Fi. I think. Let's see. Yeah, that's fine. She dropped off. Let's see if she comes back.
Jörg, do you hear me?
Yes, you're back.
Oh, my apologies. Something went wrong with my connection. But I was more or less to the end of my talk. So let me share my slide again. Yeah. Do you see the slides?
Yes.
Yeah. So, well, if you go to the B2 Share repository and search for data that is being published on the CompileMed, you see that researchers within the CompileMed already started to publish data under this repository. And I think this is a great achievement because it was not, historically, it was not like this. Like, the researchers really was not thinking about how the data can be preserved or made published in a way that it can be reused afterwards. But this mindset is slowly changing, it's very good that what we are actually offering to the community with the help of EUDAT and DICE is actually being taken up by the research community and doing proper data management and having more fair data, findable data, accessible data, reusable data. So I think this is great work. Thanks to all the efforts and supports we got from EUDAT. And again, the last thing that we tried to set up within the CompileMed community was to help them or give them a sort of data curation help desk for their data. So if they have questions about how to publish the data, if they needed support, they could contact us and reach out to us for further support. So, and this will be still running until the end of the project, which is March next year. Well, with this, I am to the end of my slides. I think I went turbo fast, but I also want to thank you, the people we have been working on from UCL, BSc, at SURF, my colleagues, and also LRZ. And also thank you for your listening. And if there are questions, I would be happy to answer.
Yeah, maybe if you get a bit.
Yeah, you can see me, all right.
Yeah.
Yeah. So I have two questions. First, a very interesting presentation. Thanks. And the first question is regarding the federation. So I assume that you have multiple B2 safe instances. You are storing sensitive data in these instances, and you are doing replication. So what about the is the replication is based on like ethical approval that, for example, the sensitive data from Spain can be replicated to the UK? Are these ethical approvals are in place? And what was the process for getting this? Because if I understand correctly, that you have replicas from all of the data in each of the B2 safe instances, which means that in each instance you have data from maybe 4 countries. So what was the legal procedure for getting this approved?
I think this is a very good question, and I was expecting that. So what I just showed so far, what we have been testing with, so the tests were all done with let's say, test data. And the use cases that we have been working with, and also in the proposal of the what we submitted in the first place, we clearly indicated that this will all be synthetic data. So no real, let's say, data with sensitive data with privacy or sensitive information will be used in this whole flow of replications, but the questions you asked is what we are now bumping into. As I showed you, maybe I can go back to my slide where we have now the workflow. So this one. So basically at this stage, even for that like non-sensitive data, which is stored in some sort of safe data haven, we are bumping into obstacles that we need to sign, for example, data sharing agreements with these between centers. And also, for example, risk assessment needs to be done at SURF and BSc to make sure what will happen qua risk if this data exits UCL data safe haven. So to be honest, I find this whole legal and let's say permission and this part of the work much more challenging than the actual technical solution we have put in place. But yeah, this is something that we are now talking with UCL and trying to see how we can push this forward to get the permission needed to extract this data. But yeah, again, the data owner has clearly gave permissions, but still, because this data that is stored here has contractual, and legal obligations, we need to sign data sharing agreements, and this is now still work in progress.
Yeah, so currently what you are implementing is a technical solution and tested it with synthetic data, and you are in the process of getting these agreements in place so that you can, but you are planning during the duration of the project that I understand will end in March, so you are planning to have a proof of concept of sharing actual sensitive data on B2Safe, or this will be after the duration of the project?
Yeah, so well, actually, the project itself, the collaboration between DICE and Combiomed, because DICE ends end of June, well, tomorrow, basically. But this is still working because Combiomed will be until end of March next year. And also, the good thing about this setup is that, for example, B2Safe is running as a service in production at SURF anyways, and also same for BSc. And so these federations will remain in place, and it's beyond the what is beyond projects. Let's say these are services that these centers are offering, So as I said, we are now busy with having these data sharing agreements in place and also risk assessment if needed. But once that is in place, I think it makes it easier for like follow-up studies or other research to be facilitated on this platform. But I fully agree with you that when it comes to sensitive data, I think it's the next level. We need to make sure what is needed for that is in place, and yeah, I see it really as a next level to replicate sensitive data in this platform. But right now, it's mainly meant for synthetic data, like simulation data and data that is being used to run simulations and models and do assessment of drugs, things like that. No association to any real data, let's say, or sensitive data.